هذا المحور الثالث لمادة نظرية الآلات Theory of Machines. Chapter 3 will start by the first part. As a chapter outcomes for this chapter, after completion of this chapter, a student will be able to determine the velocities of links and points on a mechanism. We'll start by velocity calculation in a mechanism and by instantaneous center method. As an introduction, if we consider one link AB, a solid AB, or a rigid body, if we have a combined motion, rotation, and translation, we can see here the solid AB makes a translation first. A move to A1 and B move to B dash. After that, it makes a rotation around A1, B dash moves to B1. Or it can start by rotation around A, B move to B dash. After that, it makes a translation, B dash move to B1 and A move to A1. And the final position is A1, B1 for both, even started by rotation or translation. Here we can see the initial position AB for the solid and the final position A1, B1. Okay, this is the solid and final position here, A1, B1. Motion of a pure rotation about some center I. Here we can find and we can see that the solid, the whole solid AB as a rigid body makes a pure rotation about the some center called I, sorry. This is called instantaneous center of rotation. Okay, I known as an instantaneous center of rotation, also called centro or virtual center. Velocity of a point on a link by instantaneous center method. The instantaneous center method of analyzing the motion in a mechanism is based upon the concept that any displacement of a body or a rigid link, or called also solid, having motion in one plane can be considered as a pure rotational motion of a rigid link as a whole about some center, known instantaneous center of rotation or virtual center of rotation. So if we have the rigid body, this is the rigid body, okay, a solid, and we have 2 points fixed on this solid of this rigid link. How to find I, the instantaneous center of rotation? So first, draw AI and BI perpendiculars to the directions of VA and VB. So we know that VA, this is VA cosine alpha, this is VB cosine beta. So VB is here, VA is here. Okay? How to find I? So IA, the line IA, should be perpendicular to what? To VA. And BI should be perpendicular to what? To VB. So at the beginning, we didn't know I, the point I position. What we have to do, we know VA, okay? And we know VB, it is given. From here, how to find I? We have to draw the line passing from A and perpendicular to VA, and the line passing by B and perpendicular to VB. The intersection here, it is the I, the instantaneous center of rotation. So the complete rigid body or rigid link is to rotate or to turn about the center I. Since A and B are the points on a rigid link, therefore there cannot be any relative motion between them along the line AB. So no relative motion between the point A and the point B. They move, so the distance, the distance AB remain constant, and the position of A on the solid body and the position of B on the solid body is still not modified. Okay?